All right. Good morning, everybody. How y'all doing? How was the cross country meet?
It was good.
What did you? Did you win?
I didn't advance to state, but it was fine. It was okay.
You got what? Did you say?
Yeah, I got 62nd. Like out of I don't know how many girls there were. 200 something.
Well, that puts you in the the 50 percentile, top 50%. That's a good. You were better than half the girls there. There you go. Yeah. Yeah, you were better than half the girls there. Did you have a good time though? Was it fun? Yeah. Running, fun? Well, good. Alright. Um, alright. I'm going to spend a very brief amount of time today talking about the exam. Again, overall, everybody did really good on this exam. Now, um, I'm throwing in my grade book. I have your class and another class all mixed together. Because I just instead of having two different grade books for my two ITV sections, you're all across the board. So when I talk about the statistics, it's not just y'all four that I'm talking about, but it's going to be all the other students. I have 17 in total. Um, the maximum score was 106. The minimum score is an 83. So everybody passed with at least a B. Um, the average across the 17 students was 95. So, I mean, as a teacher, I couldn't be happier with those scores. Everybody did really good. Um, there are just a few problems and I'm looking at my statistics, um, and I'm going to look at the number three most missed problems. Number three most missed problems. So the number one most missed problem. So if you have access to if you printed out your exam, or you want to go ahead and look at GradeScope as I'm talking about this, just follow, or I'm just going to pull up the key and talk about it. The number one most missed problem was problem number 20. Problem number 20. And here was the issue with problem number 20. I think everybody got the last two parts, C and D, correct. It was dealing with increasing and decreasing. When we talk about when is the function increasing and when is the function decreasing, we are not talking about the y values. We are not talking about what are the values along the y-axis. We're talking about the values that are along the x-axis. And we're using the x-axis as our guide for thinking about riding the roller coaster from left to right. And as you ride the roller coaster from left to right along the x-axis, what is the roller coaster doing? So as I start over here at negative infinity, and as I go this direction, the graph is increasing from left to right. So starting over here at negative infinity and all the way until negative 1, because at negative 1, this is our transition point. From negative infinity to 1, I'm going up the graph. And then at negative 1 is my transition point. At x equal to negative 1, I transition, and my graph starts going down. So as I'm going along the x-axis, starting at negative 1, my graph is going down, 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 all the way until I get to x equals positive 2. which we have this transition point down here. So from -1 to 2, and this, think about it as this interval along the x-axis, my graph is going down. And then the graph starts going back up again. So from 2 all the way into infinity, my graph is going up. So it has nothing to do with the y values. And I said in the notes and I said in the homework, if I could erase the y-axis, I would. If I could erase the y-axis, I would, because I don't need the y-axis to tell me when the function is going up and down. All I have to do is just look at the graph. The graph is going up, then it's going down, then it's going up as I read the graph from left to right. So this was the number one most missed problem. Which of the 17 students, if I'm reading my information correctly, only 62% got it correct. So what, 17 times 62%. So 7 students got it incorrect, 10 students got it correct, roughly speaking. The number 2 most missed problem was problem number 8. And the issue with problem number 8, any of y'all that missed this problem either missed it because you didn't answer the question, or you put the domain is from -infinity to +infinity. Well, notice here that these inequalities are everything that's less than 9 or everything that's greater than 9. There is no or equal to. So if I was asked to plug in 9, I wouldn't know what to do, because neither one of these functions tell me that I can plug in 9, so I don't plug in 9. So that's not in my domain. Now, going back to the homework, I said that you also have to look at the individual equations. Well, this first equation is a quadratic equation. The domain of all quadratic equations is going to be from infinity to infinity. So this domain does not contradict what I have here, other than the fact that I can't plug in 9. Excuse me. The domain here, we need to set this denominator equal to 0. So x squared minus 2 equals 0. Add 2 to both sides. X squared is equal to 2. Square root both sides, you get x is equal to plus or minus the square root of 2, which is a 1.4 something. Well, if I was told to plug in the square root of 2, I wouldn't plug it into this function, because the square root of 2 is less than 9. I would plug it in up here. So the restrictions on this equation aren't applied to this part of the piecewise function, because the only things that I plug into this equation are things that are greater than 9. So even though this has restrictions, they only get, the restrictions that you would have here only get used up in this equation, which I can plug in the square root of 2 in this guy and get a value out. So my domain remains -infinity to 9 union with 9 to infinity. My domain remains as that value. And then the third most missed problem was problem number 15. And I'm going to go ahead and talk about 16 as well. It wasn't the fourth missed problem, but it was pretty close. And I think that the problem with 15 and 14 were dealing with fractions. So, first of all, we have to, for this problem number 15, we have to find the slope of this given line, x plus 4y equals 7. So over here, I went through and I solved for y, I get y is equal to negative 1/4 x plus 4. That means my slope is negative 1/4. We want the parallel line, so parallel line means same slope. So that means M2 is going to be negative 1/4, same slope. Then I plug things into my slope-intercept equation, and I get y minus 5 is equal to negative 1/4 x plus 1/4. And then when you add 5 to both sides, you have to add 5 to 1/4. So we need to rewrite 5 with a denominator of 4, so that's going to be 20/4. So 1/4 plus 20/4 is a 21/4. And this is the answer that we want. Alejandro, I think you put 5 point, whatever 21 divided by 4 is, 5 point something. I still counted that correct. I prefer it to just to be left as the improper fraction, but I didn't count off for rewriting it as a decimal form. So if you missed this problem, it was either because one, we didn't solve for the slope here, or two, we didn't add 5 correctly to 1/4. And similar issues occurred down here with problem number 4. Problem number 4, we want the slope of the perpendicular line, so I've made note right here that perpendicular slopes are negative reciprocals. The nice thing here is they already give you what the slope is. It's 3. So for our initial equation, slope is 3. That means our perpendicular slope is a negative 1/3. Plug that into your point slope equation. Now you get a 7/3, so you have to subtract 2 from 7/3. So 2 with the denominator 3 is going to be equivalent to 6/3, so 7 minus 6 is going to be a 1/3, and there is the answer to our question. And at this point, I would just say that, now another thing I want to point out is the key for this, the format of it doesn't exactly match your exam, but all the questions are there. I just don't want to make the same key for 2 different formats. Again, I don't feel compelled to talk a whole lot about the exam because I think everybody did really good. What I would do if I were you is I would take the time to look at the key that's provided to you on Blackboard, and I would spend some time going over the exam, your graded exam, with the key, thinking about, all right, what did I miss? Why did I miss it? Do I understand why I missed it? Look at the key. If you don't understand, if you're not understanding why you missed something, maybe ask a fellow student. And then if all else fails, you can always email me. So spend some time to go over your exam and the exam key, mostly to have a better understanding of the material and also to think about preparing for that comprehensive final exam. Alright, so that's really all I have to say about that. So this leaves us time to talk about assignment 15. What can we look at in regards to assignment 15?
Can we go over 8?
Sure. I'm not, I'm just chuckling because that's the exact same problem that I covered in my last class, but I'll be glad to do it again. So let's go over number 8. Number 8 is what they call a doozy. All right. Let's see. Here we go. F of x is equal to a 2x to the fourth plus a 5x to the third minus a 28x squared minus an 87x minus 36 set equal to 0. All right. The very first question I'm going to ask is this. What is the end behavior? Did y'all find the end behavior of this?
No.
Alright, so let's do it together. End behavior requires us to look at that leading term. A sub n, x to the n, which in this case is going to be 2x to the fourth. And now, as we look at 2x to the fourth, we care about two things and two things only. I want to know what is n and what is a sub n. N is referring to the exponent. So our exponent is 4. Now, when it comes to this 4, I care about two things. I care about whether or not it is even or if it is odd. So is it even or odd? You tell me.
Even.
Even. Now, what does that mean in terms of the end behavior? Do we have end behavior that's the... Go ahead. What'd you say?
Nothing.
Oh. So what does that mean in terms of end behavior? Does this mean that we have end behavior that is opposite, where it's going up on one side, down the other side, or vice versa? Or does it mean that we have end behavior that's the same? It's going up on both sides, or it's going down on both sides? What does it mean? Same. You're exactly right. Same end behavior. So I'm just going to write same end behavior up here. Now, that means it could either go up on both sides or down on both sides. And we determine that by looking at a sub n. A sub n is referring to the leading coefficient, which for us is going to be 2. And we care about whether or not a sub n is positive or if it's negative. And of course, 2 is positive. So if you have exponent that is even, that means you have the same end behavior. If your leading coefficient is positive, that means it's going to go up on both sides. So I'm just going to write out and say that my end behavior is going to rise on the left, and it's going to rise on the right. Now, I don't know what it's doing in the middle, at least not yet. But we know what it's doing at the infinities. We know it's going up on both sides. Now, In no particular order, this isn't following the exact same order that I did things in the notes. I'm going to go ahead and find the y-intercept, which I think was perhaps part C, if I remember correctly. The y-intercept might be one of the easier things to do. To find the y-intercept, you evaluate the function at 0. So that means we want to know what is f at 0. And the nice thing about this is it's always going to be your constant. So if I look out here at my function, my constant is negative 36. Why is this the y-intercept? Well, as you plug in 0 for all your other x's, you get 0 plus 0 minus 0 minus 0. That all becomes 0. 0 minus 36 is a negative 36, so our y-intercept is at negative 36. So I'll just write that as 0, comma, negative 36. So I'm going to just circle what we know. We know that we have a y-intercept at 0, negative 36, and we have in behavior that rises on both the left and the right. Now, what makes this problem challenging is the next step. B, finding those x-intercepts. This is the challenging part. Mainly because if you're doing it on your own, it's going to require a lot of work. Alright, so number one, this function right up here at the top that we're looking at, it has 1, 2, 3, 4, 5 terms. I don't know how to factor a 5-term polynomial. So what we're going to have to do is we're going to have to use that synthetic division. We're going to have to go through the process of using synthetic division to find the roots of this polynomial function. This is basically what we did in assignment 14. This is what we talked about on Monday. So, let's begin. The first thing that we need are the possible rational zeros. So to find those possible rational zeros, we look at the factors of the constant divided by the factors of our leading coefficient, which is going to be 2. So, let's start listing things out. What are the factors of 36? Well, I got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 36. Those are all the things that divide evenly into 36. And the factors of 2, we got plus or minus 1, plus or minus 2. Now we have to go through and divide. So what I'm going to do in terms of dividing, I'm going to do everything divided by 1. And then I'm going to do everything, I'm going to divide it by 2. Now dividing by 1 is really easy, right? Because dividing by 1 is just whatever you have. So you get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 36. So that's everything divided by 1. Now we need to go through and divide everything by 2. So 1 divided by 2 is a half. 2 divided by 2 is 1. Well, I already got 1 up here, so I don't have to write it again. 3 divided by 2 is 3 halves. 4 divided by 2 is 2. Well, we already got that. 6 divided by 2 is 3. We already got that. 9 divided by 2 is a 9 halves. And then 12 divided by 2 is 6. Already got it. 18 divided by 2 is 9. Already got it. 36 divided by 2 is 18. Already got it. So these are our possible rational zeros. Now we begin the testing phase. Now there's 4 of y'all. 1, 2, 3, 4. Divide and conquer. Someone, and y'all need to assign this to your fellow peers. Someone test x equal to -1 or x equal to 1. Someone do x equal to -1 doing synthetic division. Someone test x equal to -1. Someone test x equal to 2. Someone test x equal to -2. There's 4 of y'all. Decide right now, amongst the 4 of y'all, who's going to do what. Who's going to do what? Y'all make that decision, and I'm going to help you out, and I'm going to do x equals to 3. So have y'all decided who's doing what? Alright, begin work. Remember, we're doing synthetic division, so I'm going to do x equal to 3. The coefficients of my polynomial are 2, 5, -28, -87, -36. Alright, Alex, what'd you do?
I did -1.
Did you get a 0?
No, sir. I got a
Okay.
remainder of 20.
Okay. What about the rest of y'all? Who's done?
I have a remainder of 71.
You did -1? Did you get a 0?
I did. I didn't get 0.
On what value?
What?
You got 0 as a remainder?
I didn't.
Okay. Good. What about the rest of y'all? Did y'all get zeros?
I didn't get 0. I solved for 2, and I got a remainder of -250.
And so none of y'all got 0 as a remainder. I didn't either. So what's the next possibility? -3. Did y'all get 0? Good. Alright, so what does this mean for us? This means that x equal to negative 3 is a 0 of the function. It's good news for us. Now, we want to keep going. Now, just as a quick reminder, since this was x to the 4th, this is x to the 3rd, x squared, x, then our constant. What we're going to do is we're going to continue with the synthetic division. But we're going to use these coefficients because it will be less work. And also, you want to continue with the last 0 that you did. Because you never know, this could be a repeated 0. This could be a 0 twice in our function. You never know. So don't skip out on it. Keep going with this 0. And those coefficients are 2, -1, -25, 12. Here we go. Did you get 0 as a remainder? Good. So, already, I'm glad we did it this route, because already when it comes to our zeros of the function, we got x equals -3, and in the notes we talk about things called multiplicity. I just abbreviate that as multiplicity. This 0 at -3 has a multiplicity of 2. Which means when we start talking about the graph and the x-axis, what is the behavior of the graph at the x-axis? Since 2 is even, this means that the graph is going to bounce at -3 on the x-axis. We're going to have this bouncing behavior. It's going to touch and turn. So, but that's not all the zeros. We're not done yet. We got to keep going. So this was x to the 3rd. This is now x squared, x and our constant. Excuse me. That should be 2x squared minus 7x minus 4 equals 0. And once we get to a quadratic equation, I abandon the synthetic division. I stop, and I'm going to solve this by either factoring or completing the square. So when I look at this, the first thing I think about is, can I factor it? So if we think about the AC method, I'm going to take the factors of a times c, so 2 times 4 is a -8. And I'm going to ask the question, are there factors of -8 that add up to a -7? And the answer is yes, a -8 and a +1. This will factor. Now you could use the quadratic formula if you want to, but I'm going to solve this by factoring. And at this point, I'm just going to go straight to the factored form. You know how to factor, or you should know how to factor at this point. Because we have this 2x squared in front, the only way to make a 2x squared is take a 2x times 2x. Now, remember what I said earlier? I was doing the AC method. AC is equal to negative 8. B is equal to a negative 7. So I need a negative 8 and a positive 1 to make this negative 7 right here. So how do I make a negative 8? Well, I'm going to have to take that 2x and multiply it by a negative 4. And how do I make this positive 1? I'm going to take 1 and multiply it by x. So there's the factored form of this quadratic function, which then means we have 2x plus 1 is equal to 0, and we have x minus 4 is equal to 0, which then means that we have x is equal to a negative 1/2, and x is equal to 4. And that, ladies and gentlemen, are our two remaining zeros. So, going back up here to this list of zeros, we already said that we had a 0 at negative 3. We already talked about its multiplicity, and what that means. It means it's going to bounce on the x-axis. And then I'm going to list my other zeros. I have a 0 at negative 1/2 and a 0 at 4. Both of these have multiplicity of 1, which both of these are odd. What happened? Both of these are odd. So that means that they are both going to cross the x-axis. So at this point, we have enough information to start getting a sketch of our graph. So here we go. I think we have enough space right here to do it. Now, let's just go ahead and plot the x-intercepts. Now, the way I'm going to do this, and it isn't, as long as you're consistent with your graph, I'm going to plot this such that every other box is a value of 1. Makes it really easy to plot negative 1/2. So let's just plot those points. We have a 0 at negative 3, we have a 0 at negative 1/2, and we have a 0 at 4. Now the next thing I'm going to think about is my end behavior. I'm thinking about all this stuff at once. So I'm just going to go and think about my end behavior. It's going to rise on the left, rise on the right. So I'm just going to put little arrows. And the next thing I need to think about is my y-intercept. It's at negative 36. Alright, so this is going to be interesting because negative 36, even if I'm just got to scale my graph appropriately. So how am I going to do this? Because I know what this graph is about to do, call that negative 20, negative 40, negative 60. Because I know what this graph is about to do, I'm going to scale it like this. Actually, let's do every 10. Negative 10, negative 20, negative 30, negative 40, negative 50, and so forth and so forth. Alright, and so we'll roughly estimate where's negative 36, right about here. Now, from here, without graphing any other points, I will accept this graph so long as it matches the end behavior, and our multiplicities. Now, the only place that this graph is ever going to touch or cross the x-axis are at these 3 points. Do not force your graph to behave by making it cross the graph at any other point. These are only 3 places that it can touch or cross the graph. At -3, it's going to bounce. So if my graph is rising on the left, at some point it's going to have to come down and it's going to have to bounce at 3. Let me do a little bit better job about this. There it is, bouncing at -3. Now, the next point that my graph has to interact with is at this -1/2. So at some point it has to come up and then come back down. And what is it doing at 1/2? It's going to cross the x-axis. So it's going to go through that point. Now look at the trajectory. It's going to go through the y-axis. Now we're just sketching this out. It's going to go through the y-axis. Now look at the next point that it has to interact with. It has to interact now with the x-intercept at 4. So it has to come down and then come back up through the 4. Now, in all honesty, I would accept this as an acceptable answer. Why? Well, it has the correct end behavior. It rises on the left, it rises on the right. It has the correct x-intercepts. -3, 1/2, 4. It's also behaving correctly at each x-intercept. The graph is having to bounce at 3. Now, if you didn't show that it was bouncing, just follow my pencil. If you didn't show that it was bouncing, it would cross, and then you say that it would cross here, but look where you're going. If you cross here and then come back up, you're missing the y-intercept. Then you'd have to come back down. Well, if you came back down, you'd have another x-intercept. If you crossed here and then came back up, you'd have to go back down to interact with this y-intercept. Well, going back down would mean that you would have a 4th x-intercept. There is no 4th x-intercept. So don't force your graph to behave the way you think it ought to behave. If you're forcing the graph, that means you're doing something wrong. It has to bounce at 3, come up, then cross. It goes through the correct y-intercept, and then it has to come back up through 4. Now, if you look at the graph on the enter key, you'll notice that it goes down really, really far. So, one thing that you can always do is you can always plot additional points. The more points that you have, the better off your graph is. So let's say that we want to find f at -2. So in my calculator, I'm going to do -2, enter. And now I'm going to use my answer function down here to help me with this function. I'm going to come over here and I'm going to type this function into my calculator. Now, I've already done this because I did it in the last class. And here it is. 2 times answer raised to the 4th power plus 5 times my answer raised to the 3rd power. And then we have minus 28 times the answer squared minus 87 times the answer minus the 36. And if I hit enter, I get 18. So that means at -2 we have 18. So I can plot that. If this is 10, 20, 18 is going to be right about there. Then if I want to keep going, f at -1. The nice thing about having this locked in my calculator is I can just go through and do -1, enter. Oh, we get 20. So now my graph looks more like this. So what's it doing at 1? F at 1. I'm going to do 1, enter. Oops, that's 11. 1, enter. -144. F at 2. 2, enter. Then look at that same expression. -250. F at 3. -252. Well, gee, Mr. Clopton, it looks like it's just going down and down and down. Well, look what happens when you plug in 4. 4, enter, 0. Because why? 4 is a 0 of the function. So, I don't, how far down is 144 and -250? I mean, we're probably talking not even farther than that. Probably talking like down here, maybe, and then further down. So really the graph is doing something like this. You gotta do those sound effects. It helps with the growing. There's what a graph is really looking like. Again, is this a scale? Probably not. But does it match the behavior of the graph? Yes. Alright, so does that make sense? Problem number 8. What makes problem number 8 difficult is finding those x-intercepts. How have y'all done with the rest of the problems? Alright. We don't have a whole lot of time left. Did y'all get the rest of the problems? Are there any other questions that y'all have? No? Alright. Let me talk about one thing real quickly. On a quiz or exam, again, what made this last problem number 8 difficult was finding those zeros. Because if you look back at our work, we didn't find our first 0 until we plugged in -3. So that's 1, 2, 3, 4, 5, 6. We didn't find our first 0 until our 6th synthetic division. I won't do this to you on an exam or a quiz. Typically, and I usually give this 100% guarantee, so I'll just give you my 100% guarantee. If you look at the first the first 4 possible rational zeros, so in this case that would be ±1, ±2, I have a 100% guarantee that you will find a 0 within these first 4. If your first 2 rational zero or possibilities were ±1 and then ±3.
Your conference is scheduled to end in 2 minutes.
So there was no 2, I would have again 100% guarantee that you would find it either by doing the ±1 or the ±3. 100% guarantee that you will find a 0 within your first 4 possibilities. Now is determined by, one, did you do everything systematically? +1, +1, -1, +2, -2. Don't skip around. Don't do 1, 2, 3, 4. Make sure you do the negatives. So do things systematically. And secondly, that your arithmetic is correct. It's easy to mess up the arithmetic here, so take your time with the arithmetic. Um, but again, 100% guarantee that you will not have to do more than 4 synthetic divisions to find your zero. Most of the time, I don't even like to get to 4. Maybe 3 might be the highest that I do, but I've done 4 before. Maybe that'd be a good bonus problem. So, final thoughts, make sure that you spend time before Friday looking over the notes for assignment 16, graphing rational functions, and you spend time looking at the homework. Again, that's another heavy graphing section, and I will address your questions over that assignment on Friday, and we'll also have a quiz on Friday. Alright, so that's all I had to say. Y'all have a wonderful rest of your day.
Your
and I'll see
conference is
y'all
now over.
on-
Goodbye.
See you on Friday. Bye.